Hello students, this is Professor Chalai, and in this video we're going to go over some of the things that you need to know for your precipitation lab. This video will be divided into five sections. We'll look at writing ionic equations, finding limiting reagent, finding the theoretical yield, finding the percent yield, and testing the supernatant solution. You can skip forward to any of these sections that you think you might need. Let's get into it. So for a virtual pivot lab this week, we'll look at a precipitation reaction, which is just a fancy type of double displacement ionic reaction between two different solutions. Now, I'm not going to use the same combination of solutions as our prelab, but I'm going to use silver nitrate, AgNO3, an aqueous solution, and magnesium chloride, an aqueous solution of magnesium chloride, and we're going to be in the examples that I'm going to use for this prelab are going to involve these two compounds. Okay, for a silver nitrate solution, let's assume that you started with a concentration of 0.100 molars and you used 10.0 milliliters of the solution. Whereas for the MgCl2, let's just assume that you started with 1 gram of the solution. And then you dissolved it in water to make the aqueous solution. Doesn't matter how much water. When you mix these two together, you might see a reaction happening. What reaction is it? Well, let's figure it out. A double displacement reaction would exchange the cations and the anions from your reactants into your products. So let's see what we'll get. So for silver nitrate, if we divide these into its ions, we'll get silver plus and NO3 minus, that's a nitrate ion. And for magnesium chloride, we get magnesium 2 plus and 2Cl minus ions. So in a double displacement reaction, we'll take the cation from one compound and mix it with the anion for the other compound. So we'll get AgCl. They both have, one has a charge of +1, the other one -1, so we just need one of each to make it balanced. And then for the other mixture, we'll have magnesium 2 plus and NO3 minus come together. Since magnesium has a charge of 2 plus, we'll need two of the nitrates to balance it. So we'll get MgNO3 2. If we look at our solubility charts, we'll see that silver chloride is insoluble, so that'll be a solid, whereas magnesium nitrate will be aqueous. So that is our reaction so far. And then to balance these, we'll notice that we have one silver, that's good, one nitrate, two nitrates, so that's not good. Let's make this a 2. That gives us 2 silver on the left. Let's put 2 on the right to give us 2 silvers. And now we have 2 silvers, 2 nitrates, 2 chlorides, 1 magnesium. Everything should be balanced. Okay. In writing so this is what we would call the molecular equation. I'm just going to show you briefly how to write the complete ionic equation. So complete ionic equation. We break apart everything that's aqueous in a complete ionic equation. So we have 2 silver nitrates, so that means we will get 2 silver aqueous plus 2 nitrates aqueous. And for magnesium chloride, we'll get 1 magnesium 2 plus aqueous plus 2 chlorides aqueous. And on the product side, we'll get 2 silver chlorides solid. We don't break it apart because it's solid, not aqueous. We'll get 1 magnesium 2 plus aqueous. We break that apart. And 2 nitrates aqueous. And now for net ionic equation, we just look at all of the ions that are the same on both the left-hand side and the right-hand side. We find that nitrates are the same on both sides. Magnesiums are the same on both sides. So all we're left with is 2 silvers aqueous plus 2 chlorides aqueous to give us 2 silver chloride solid. And we can even get rid of the 2's because we can do so. And so this is our net ionic equation. The net ionic equation, if you'll remember, is the only thing, involves the things that are changing in this reaction. Really, they're the only things that are reacting. Everything else are just spectator ions. which means that our interesting product in this reaction is going to be our silver chloride. So let's keep that in mind. This is our interesting product. And this is a precipitation reaction. So precipitation reaction, because we go from all solutions, aqueous solutions, to a solid product that will precipitate out, a solid precipitate. Okay, so this is our interesting product that we'll be interested in, silver chloride. Let's now talk about finding the limiting reagents. So I mentioned that we started with a concentration and volume for each of these solutions for the silver nitrate, and we started with a mass of the magnesium chloride, and we formed some interesting product. Now, unless you mix these two solutions in the perfect amount, usually you'll have one that's too much and one starting solution that's too much or too little, and another that's too much or too little. So one of the starting solutions will typically get used up first. So let's look at how we figure out which one gets used up first. The one that gets used up first is called the limiting reagent. So let's find which one it is. Okay, so we started with silver nitrate and magnesium chloride. Let's first focus on the silver nitrate. So let's focus on the silver nitrate. And let's first find the number of moles of silver nitrate. We started with 10 mils of silver nitrate. So we started with 10.0 milliliters. And the concentration was 0.100 moles over liter. So if we convert milliliters to liters by using 1000 milliliter is equal to 1 liter, we'll find the number of moles of silver nitrate, which just happens to be in this equation 0.00100 to 3 mole. So that's our moles of silver nitrate, but that is not the product that is just the reactant. Let's look at, if we used up all of the silver nitrate, how much product will we form? So let's figure out how much product, which is number of moles of silver chloride, we can form from this. So we start with 0.00100 moles of silver nitrate. And then using this balanced equation, we find that for every 2 moles, so right here, for every 2 moles of silver nitrate, we form 2 moles of silver chloride. So let's put that in our equation. So for every 2 moles of silver nitrate, we form 2 moles of silver chloride. And so that's how we can convert from moles of silver nitrate to moles of silver chloride. That cancels out, and we'll end up with 0.00100 moles of silver chloride. Okay, so if we used up all of our silver nitrate, this is how much silver chloride will form. Let's look at the other reagent. Let's look at magnesium chloride now. So let's figure out how much moles of magnesium chloride we started with. Well, we started with 1.00 grams of magnesium chloride. And to convert grams to number of moles, we need to find the molar mass of magnesium chloride, which is just equal to the molar mass of magnesium, which is 24.31, plus 2 times the molar mass of chlorine, is 34.45 grams per mole, which gives us a molar mass of 95.21 grams per mole. So let's use that, 95.21 grams per mole. Grams cancel out, and we'll end up with 0.0105 moles of magnesium chloride. Okay, so if we use up all of our magnesium chloride, how many moles of our interesting product, silver chloride, will we form? Well, we have 0.0105 moles of magnesium chloride. From our equation, we see that for every 1 mole of magnesium chloride we use, we'll form 2 moles of silver chloride. So for every 1 mole of magnesium chloride, we'll form 2 moles of silver chloride, which is our interesting product. So if we do that math, we end up with 0.0210 moles of silver chloride. Okay, so if we used up all of our silver nitrate, we'll form 0.001 moles of silver chloride. If we use up all of our magnesium chloride, we'll form 0.0210 moles of silver chloride. This means that the one that gets used up first is the one that forms the smaller amount of product, which means that in this case, that would be the silver nitrate, which means that silver nitrate is the limiting reagent. It's the one that gets used up first. And when it gets used up, the reaction stops and magnesium chloride will be left over, and so this is called the excess reagent. Okay, so now that we figure out what our limiting reagent is, here we go. We can now go and figure out what our theoretical yield is, because our theoretical yield will depend on however much product we can form if we used up all of our limiting reagent. So in that case, if we use up all of our limiting reagent, we'll form 0.001 moles of silver chloride. So let's look at our theoretical yield. We'll form 0.00100 moles of silver chloride. That is our yield. However, we usually measure our solid product on the scale. We'll measure it in grams. So let's find our theoretical yield in grams. And to convert moles to grams, we need to find the molar mass of silver chloride, which is just the molar mass of silver, which is 107.87, plus the molar mass of chlorine, which is 35.45 grams per mole, which comes out to be 143.32 grams per mole. So if we use that, so theoretical yield will be our moles converted to grams. So it's 143.32 grams per mole. So that moles cancel out. And we should get 0.143 grams of silver chloride. And that is our theoretical yield. Theoretical yield in this sense just means that what we could possibly get if we used up all of our limiting reagent. However, we'll find oftentimes we do not get all of the possible product you can whenever you do these experiments. For example, let's say you mix the experiment, you find some precipitate, then you filter it out. So you filter out all of the solution, and so you're left over with the remaining precipitate, and then you measure it on a scale to see how much you get. Let's say in this case, we measured, instead of 0.143, we measured something like, I don't know, 0.084 grams of silver chloride after we actually performed the experiment. What will be our percent yield? Okay, let's look at that. So our percent yield will just be how much we actually got. So let's use different font. Actual, or let's use a better word, sorry, measured yield divided by our theoretical yield, all times 100%. And so in this example, our measured yield was 0.084 grams. Our theoretical yield was 0.143 grams times 100%, and that will give us about 59% yield. So our percent yield is how much you actually got compared to how much you could have theoretically gotten from your theoretical yield. Okay, and finally, I want to talk about the supernatant solution and how we might test what's in there. So I mentioned that you perform this solution in a beaker and there's some precipitate. And so what you would then do is you set up a filter and you would filter out the solid precipitate and you would collect whatever is left over And whatever's left over is called a supernatant. It has everything except the solid precipitate. So if we look at our equation again, we had our balanced equation was 2 silver nitrates aqueous plus magnesium chloride aqueous plus our 2 silver chloride, which is our solid precipitate, plus our magnesium nitrate aqueous. So this was our reaction. Sorry, this was supposed to be a right arrow. There we go. So this is our reaction. This is our filtered product. So once you filter it, you've removed it from the solution. So for all our intents and purposes, this one gets used up. It's no longer there. It's filtered off. We found that this was the limiting reagent, which means if it's a limiting reagent, it gets used up, so it's no longer present. So in our solution, what we have left over are these guys. This was excess, so there are going to be extra of these left over. So what we'll have left over are going to be the ions from magnesium chloride, so it'll be magnesium 2 plus and chloride minus. And we'll have this left over after we filter as well. So we have magnesium again. I'm not going to write that again. It's already over here. And we'll also have nitrate minus. So what we have left over after we filtered off and used up all of the limiting reagent are going to be magnesium ions, chloride ions, and nitrate ions. Usually to test whether this is the case, so to test, we're going to add solutions to it to see if anything happens. So if we add, for example, some more silver nitrate, so an AgNO3, to the leftover solution, what might happen? Well, all the ions might mix together, but the interesting thing that might happen is the silver plus and the chloride that's left over will react to form more silver chloride solid. So this is a good way to test if these are the ions left over in our supernatant solution, is to add more silver nitrate to see if we form our solid precipitate. Let's just do the opposite. Let's add the other reagent, which is magnesium chloride. The magnesium will not react with and form precipitate with any of these. The chloride will not react to form precipitate with any of these. So nothing should happen if we add magnesium chloride. And so this is one way to test what was the limiting reagent. If we added silver nitrate to the supernatant and stuff happens, silver nitrate was the limiting reagent, and because we added more, we let the reaction continue again. Whereas if we added more MgCl2, this was already the excess, so adding more doesn't change anything and doesn't do anything. All right, so this brings us to the end of my pre-lab talk. I know it's long, but I've gone through all of the different sample calculations that you would need for this lab, including how to write various types of equations and calculating various types of yields, and even how to test the supernatant solution. If you have questions about this lab, please message one of your instructors, and I'm sure we'll be able to help you. I'll see you in the next video. Bye.